Hey everybody, welcome to Science. So we're going to be talking about forces in this video. We've done some work with forces in the past, and we're going to talk a little bit more about those now. If you recall, one of the things that we've talked about is a force is a push or a pull on any object. So anytime you have a push or a pull on an object, that's a force. So here's a few silly examples that I found around the house: turning and closing a faucet outside. And then, of course, rocks. If you're lifting a rock, that's a lot of force. And then this one, oh my gosh, too much force in that one. So while we've been talking about forces, we've also talked about how we measure forces. And we use that unit newtons, named after the guy who got bonked in the head by an apple, Sir Isaac Newton, father of all physics. So when we're measuring forces, we also have to remember it's that force equals mass times acceleration. So I'm going to take this really weird collection of nuts and bolts that I found. I've got it on a spring scale. So when I look at this, I'll just bring it up to the camera and hopefully you can see it. Looks like we're measuring somewhere about 1.75 newtons. And I also have a gram measurement on the other side, and that's pretty close to 175 grams. So we're going to look at how do we make some of these force calculations, and we're going to talk about how forces affect us as we start talking about systems and simple machines. So now we're going to talk about how to calculate some of these forces and masses and accelerations as well. And earlier in the past, we've used a handy little idea to help us get set up with these calculations. We've taken a triangle and we've set that up to give us some formulas. So for our force triangle, we've used this in the past, and we've had force equals our mass times acceleration. So we get mass times acceleration. And so we can use that to actually find out our different units, our different calculations. So we can also reorganize this. So remember, if we were going to just calculate what the mass of something is, I would just put my finger over what the mass is, and that would show me then that what I'm going to do is I'm going to say, oh, well, let me change my color on that. Mass would be force, and whenever things are on top of each other in here, this means that they'd be divided. So force divided by acceleration. And if I wanted to take a look and see, if I wanted to take a look and see what the acceleration of something was, I would cover up the A, and I'll use green for this one. And so the acceleration of an object is going to be equal to, again, its force divided by the mass. And so our little force triangles can help us out with that. A couple of things to keep in mind. We do have special units for everything. So whenever you're doing your force, your answer is going to be in newtons. Our mass needs to be measured in kilograms. If it's not in kilograms, you need to convert it. And our acceleration is always in meters per second squared, or basically how much am I increasing my speed by every second. So we're going to put this into play and do a couple example questions here. So a good idea whenever you're doing these is look at the information that you're given. So a chair has a mass of 15 kilograms. So I'm going to write down, well, its mass is 15 kilograms. I'm going to write down what I'm given. And it moves at 2 meters per second squared. That should have been squared. 2 meters per second squared after it's been pushed. How much force is being applied, or how much force was used? So we do know that we have to calculate our force. And if I take a look at my force triangle, I get force is equal to Get rid of this. Force is equal to mass times acceleration. So if we go back to my question here, I get mass multiplied by my acceleration. Now, because I've written down all the things I've had over here already, what I can do here is I can just change my letters into those values. So I know my mass is 15 kilograms. I'm going to multiply that by the acceleration, and the A's are going to be replaced with 2's. So I get 15 multiplied by 2, which is 30, and my units for force are going to be newtons. So I could say, therefore, there was a force of 30 newtons applied to the chair. So we're going to move on and take a look at another question here. And I'm just going to draw out my force triangle here to help me out with this. So I know that its force is equal to mass times acceleration. I'm going to change to a different color here for a couple of things. So again, a rock was accelerated at 2.5 meters per second squared. So I know that my acceleration is 2.5 meters per second squared. If 40 newtons of force, so I've been given my force this time. It's 40 newtons was used. What is the mass of the rock? So I need to calculate what the mass of this rock is going to be. And the way that I'm going to do that is I'm going to use my force triangle. So I'm not using my mass. I'm actually going to put that down here to say, mass equals. And so I get my F on top of my A, which means my force is going to be divided by my acceleration. So I'm going to take my numbers that I've already listed up here, and I'm going to replace my letters with the numbers. So the F should become a 40. I'm substituting my values right now. And the A should become a 2.5. So this is 40 divided by 2.5. And that's going to give me an answer of 16. And my M's are always measured in kilograms. So 16 kilograms. So I can make my concluding statement. Therefore, the mass of the rock was 16 kilograms. That's a heavy rock. So it took a lot of force to move that. So this in general is how you're going to use these questions. And you can do the same with an acceleration question. If you're given the force and the mass and asked how fast it's been accelerated, you can answer those questions as well. Again, this force triangle is going to be a huge benefit to you. So one thing that you want to do in all of your questions, all of your notes that you're going to do, is you probably want to write this down somewhere or include it. And again, these are the different ways that you can get formulas from there. The reason we use the triangle is so that you don't have to memorize all of those. And another important thing to keep in mind is that all of our items that we're using have specific units to use, so make sure that you're including the correct units for those. All right, everyone, that's our quick introductory lesson on forces and how to calculate some things based on forces. Some of it should be a reminder from earlier in the year, hopefully. So any questions, please feel free to reach out to me. Thanks.